Hey, fourth graders, I hope it's going well. I hope you've started your trials. You might be even done. Even if you're not done, I want you to take a look at the data I recorded. So I did have a friend help me with my data collection. So I want you to kind of take a look at this data. And then biggest thing is, we do these things. We do the experiment, we record numbers, but sometimes we don't really understand what those numbers actually mean. So let's make sense of the data. So you can even review your data as well. And even if you're not done yet, if you see some errors in your data, we can check it out here. So as you can see, I have all my data here. I have my control group launch arm, and I measured the launch arm. It was 7 centimeters. And then my medium one was 12 centimeters. And my third launch arm, the longest one, was 20 centimeters. And you can see here's my distances. So I had 5 distances: 90, 92, 88, 90, 93. Notice very similar, and this is good. This tells me that I followed all the rules pretty well. I set up my setup conditions. I didn't change around anything. So this is good. If you see numbers that are very close, that's a good thing. If I got numbers that were all over the place, like if I got like 90 and then I got 200 and then I got 56, that's telling me something is not right. I'm doing something wrong because the numbers should be pretty close. Now, it's possible that you do get an outlier. Maybe a marshmallow hits an object like a table or a chair. You could redo that one if you get an outlier that doesn't really fit with the other numbers. So I took my 5 numbers here, and then I have my average. So how did I get my average? So I added the 5 numbers up. So I had 5 numbers, I added and got that total. And then I divided by 5 because I had 5 trials. So you add your add-ins, you get that number, and then divide by 5. So my average is 90. So it went an average distance of 90. And notice when you do average, your average should always lie somewhere between your range, whatever your numbers were here, your range of numbers. If it's outside of that, so if my average said 98 or something, that would be pretty impossible because I didn't have any numbers that were 98. That's what you have to look at there. So if your average does not fall between your range here, you must have did some addition incorrectly or you divided incorrectly. Okay, and then notice for my time, I rounded off about 1 second. But that's easy to do. So if I add those up, that's 5 divided by 5, 1 second. So what does this tell me? So this tells me for every second, my marshmallow traveled 90 centimeters. That's the speed. That's actually how you could talk about speed. So it would be 90 centimeters a second. Very interesting. So for every, and I just did a little division there. 90 divided by 1 is 90. So that's how you can get the speed. So for every 1 second, it's traveling 90 centimeters, okay, in 1 second. So let's drop down to our medium launch arm. You can see my numbers pretty close together, not too far off. I got 149 here, but that doesn't really bother me because they're still within a really good range here. And notice here's my average, which is fine. It falls in with these numbers here. So remember I added the 5 numbers and divide by 5 because I have 5 add-ins. I did 5 trials. So my average distance, so you notice, did it increase or decrease in my average? So 155 centimeters. And notice my time's a little different. Okay, so it's going took a little bit more time, 1.8 seconds. I left that 0.8 in there. That's very important that I left that point in there, that 0.8. For my seconds, I would definitely leave that in there. Okay, and then let's drop down to the last one. So my long launch arm, you can see my numbers here, pretty good. Not too bad here. And then my average distance. So notice, is my distance increasing or decreasing, staying the same? Okay. And then look at my time. So 1 second, 1.8 and 2 seconds. Very close. I mean, 2/10 of a second is nothing. So I would say these are very close to each other. So this tells me something very interesting because the time is pretty even by 2/10. So notice, for every 2 seconds, and how I can do that, I can actually find the speed. So I can actually find the speed. So let's do this one here. I'm going to take 273 and I'm going to divide it by 2. So I have my calculator here, 136.5. So that would be my speed, 136.5 meters per centimeters per second. Okay, so for every second, my marshmallow is traveling 136.5 centimeters, 136.5 centimeters. Okay, so let me go up to here, which is, this is almost 2 seconds. So I'm going to do the same thing. I'm going to take 155 divided by 1.8, 86 centimeters per second, 86. Okay, well, 90, this is 90 centimeters per second. This is 86, so it's actually, it's slowed down here a little bit, but it got faster here. So that's very interesting that it actually slowed down. So it was slower here, but faster here because it covered more distance per 1 second over this one here. And that I could totally tell right away because these seconds were so close to each other. 1.8 verse 2 is very similar. And notice how much more distance it covered. So I know there was an increase in speed here. So this was actually surprising once I did the calculation for this one, that it actually slowed down. So that's very interesting data. And that's why it's important to look at your data and make sense of what is happening. Very easy to see it did increase in distance. And we think, wow, maybe it's just going faster. But as I found out, it actually slowed down a little bit here between these two, and then actually did get faster here. And then you have to add in your observations. So think about, what did the marshmallow do? Well, I noticed when I did this, the long launch arm, the marshmallow traveled more in a straight line, like a line drive, other than these here. It kind of went up in the air a little further. It looked like it was lobbing up in the air a little bit more, especially this one. It looked like it stayed up in the air a little longer, but this one was more like a line drive, because you can tell, look how much further it was traveling, and almost the same amount of seconds. So you have to take that into account, as make observations as how the marshmallow was traveling. Was it like going far up in the air? Was it going like a line drive? Because that can make a total difference in your speed. So very interesting data. So how is your data looking? Are you getting good numbers? Is it increasing, decreasing, staying the same? Well, check it out. Check out your data. And then the final thing, I went ahead and I did want to graph my distance. So I went ahead and did that here for my, and this paper is online, and hopefully you will have this data chart. If I can line it, I'm upside down, so. There we go. So I did want to make a quick little graph of the distance. So I want you guys to graph the distance the marshmallow traveled in centimeters. So notice my scale. So I went up by 100 because my highest number was 300. my lowest was 88 in my trials, but my averages were 90, 155, 273. Notice you only do the averages. So for my short launch arm, my average was 90, so I made my graph just below 100. And notice I used the whole space. So you really want to think about your interval and how you space out your scale here. So that's what I did for this one. And then my second average for my 12 centimeter launch arm was 155. So I made that just above the halfway mark. And I know you'll make your graph a little bit better than mine because you guys are awesome artistes. And then my last launch arm, 20 centimeters to 273. So you can definitely see, and that's what a graph is meant to do. It's a visual representation. I should be able to look at your graph and in 10 seconds understand what happened. I can definitely see that, wow, the longer the launch arm, the further it went. And then you can also look at your time and see how that, what was the relationship, which we already talked about a little bit. So that's a little bit into data. So hopefully you've either finished your data or you're still working on it. So if your data is sort of in line with what I'm doing, excellent job. If you see some things that you might need to redo, any trials or anything like that, you can do that as well. So great job, everybody. This was a tough project, so we just want you to understand what all these numbers mean. We take all these data measurements, but we really want to know, what does it all mean? So great job, guys, and we'll see you next time.